next to the linear measurement instruments like the screw gauge, vernier head gauge, there are another instruments called comparators. So the comparators are also used in the linear measurements. So the comparators are the precision measuring instruments which are used to compare the actual dimensions with the standard, that is block gauges. But the block gauges do not measure the actual dimensions, but only it compares with the standard. The users, the comparators are used as a working gauge and for calibrating the working gauges and as a final inspection gauges. There are some characteristics that good comparator should possess. One is the robust design and construction, linear characteristics of the scale, high magnification, quick results, versatility, free from backlash, quick insertion of workpiece. So these are some essential characteristics a good comparator should have. There are many classifications of the comparators: mechanical comparator, optical comparator, mechanical optical comparator, pneumatic comparator, electric comparator, electronic comparator, fluid displacement comparator. Now let us discuss about some mechanical comparators. Before dealing with the comparator, whatever may be the type of the comparator, the principle is first in the comparator, the dial is adjusted to the 0 with the gauge block in position. So we know what the measurement is to be measured. Accordingly, the block gauge or slip gauges are set, and the comparator with its sensing device is made to touch the block gauge so that the dial is adjusted to 0. Now, in the place of block gauge, the workpiece is inserted. Then the pointer is checked whether it is shows the 0 or any deviations. Here, the deviations refers the deviation from the actual dimensions of the workpiece. So the dimensions may be equal or less than or higher than the standard dimensions. So it is in that way, the principle applies to all type of comparator. Now we look into the mechanical comparator. First, we deal the dial indicator. So the diagram shows the dial gauge. It is the simplest type of mechanical comparator. Here, the dial indicator or dial gauge consists of a base and a rigid column. So the rigid column also carries an arm. The arm carries the dial gauge. The base and column are not shown in the diagram. The arm can be the arm can be slided vertically up and down, and also the arm can be swiveled conveniently at any degree. There is some facility. Now a pointer will slide across the readings 0 to 100. Each division is 0.01 mm. Here, the bottom, there is a plunger. So the stem coming from the bottom of the container, the plunger, and plunger ends with a ball. So the ball only touches the surface to be touched. Now, as usual, the block gauges are set as per the dimensions to be checked for the linear measurements. So after the contacting the ball with the block gauge, the pointer is the dial is adjusted to 0. Now the block gauges are replaced by the workpiece for which the linear measurement is to be done. Here the pointer may indicate 0 or may deflect. So if the point deflects, the deviation is there. And also there may be also a case the ball may not touch the workpiece. So the both are deviations from the standard dimensions. Here, if the ball does not touch the workpiece, here there is some gap. So the gap can be balanced with the appropriate blockages. So the thickness of the blockages stacked together will give the deviation from the actual dimensions. So in that way, the dial gauge is used. Next to it, Johansson microcator comparator is also a mechanical comparator. Now let us discuss show the construction of the Johansson microcator comparator. Here, the instrument mainly consists of a metallic strip which is twisted metallic strip of particular length. At its center, there is one pointer. Here, the pointer will slide over the scale which is adjacent to it. So, the one end of the metallic strip is connected to the cantilever strip, and another end of the strip is connected to the spring strip elbow. Here, the one side of the spring strip elbow supports the plunger centrally. The plunger will move up and down through a slit washer. So the slit washer, as shown in the diagram, concerns the motion of the plunger only in vertical direction, that is up and down. So it restricts the sideward movement of the plunger. Okay. Now, if there is the movement of the plunger, in the twisted strip will change its length, thereby the pointer will deflect through a certain angle. So first, as discussed in the principle of the comparator, the blockage is set and the scale is set for the 0, and in that place the blockages are replaced by workpieces. So if any change, the pointer will deflect. So if the plunger moves, the pointer will deflect. So it will cause the twisted strip will change in length. Okay. As shown in the pointer at the center of the twisted strip rotates for an amount d theta. For an instant, let us consider an example. So if there is any deviation, the plunger will move up or down. So the strip rotates an amount d theta against a circular scale proportionate change in length dl. Okay. So dl and 2d theta are the parameters used. So these parameters are used for the magnification. Here, the d theta by dl is the amplification of the instrument, which was by experience was given in the empirical formula minus 9.1 L divided by 9 W squared N, where the L is the length of the metallic strip measured along the neutral axis. W is the width of the twisted strip, and here N represents the number of turns of the metallic strip, and theta is the twist of the midpoint of the strip with respect to the end. So from that we can know compare the workpiece with the standard blockage. Thank you.